Today on the Clean Power Hour, a heat battery for decarbonizing industrial heat. I'm Tim Montague, your host. Welcome to the Clean Power Hour. Check out all of our content at cleanpowerhour.com. Please give us a rating and a review on Apple and Spotify. And check out our YouTube channel. We have a wonderful YouTube channel. Just go to cleanpowerhour.com and click on the YouTube icon there. My guest today is John O'Donnell. He is the CEO and founder of Rondo Energy. Welcome to the show, John.
Thank you, Tim. It's a pleasure to be with you.
Really excited to get into a thermal battery, and you're using some very tried and true technology in some new ways. You know, we, as I like to say, my listeners will be familiar with this. We get 5,000 to 10,000 times more solar energy hitting the earth than all of humanity uses, right? We have way more solar energy and wind energy than we could possibly use. And so the only question is, how do we get enough technology out there to capture some of that energy and green the grid and decarbonize the economy? It's not a matter of resources, so to speak. It's a matter of deploy, as Jigar Shah likes to say. So what is Rondo Energy, and why did you get interested? This is not your first energy gig. So how did you get interested in clean energy?
So you're right. This is not my first clean energy gig. My first job was working in the fusion power industry, and I built companies in the computer industry after that and in the semiconductor industry. But I came back into the solar industry 18 years ago, driven by the notion that we are at this moment in history where solar technologies are coming to the point that they deliver energy at lower cost than fossil fuels in the electricity sector first, and we're now just on the moment in the industrial sector. And if we can harness wind and solar energy and have them be cheaper than business as usual, that creates the conditions for giant private capital flow that causes deploy. So in my career, I've taken new technologies to large scale with that focus of how do we get them to the point that they're tailwinds for deploy. We started Rondo because we saw this opportunity to make a contribution on a very big problem and go to very large scale in solving that.
Yeah. In the pre-show, we were talking about just how big a problem industrial heat is, and you're going to show a slide in a few minutes, explaining visually just how big thermal heat, how big an emitter thermal heat is from the industrial sector. And combined with electricity, it is the largest source of greenhouse gases. So we have a big problem. And there aren't a lot of quote unquote clean solutions to industrial heat. Of course, you see green hydrogen in the news a lot, and hydrogen does have some characteristics which are favorable. You can make it from water, for example, with electricity using an electrolyzer. It is very difficult to move it around, though, because it's such a tiny molecule that it wants to escape. And so it's kind of expensive, infrastructure-wise. And we do have an industrial hydrogen economy. It's mostly getting hydrogen from fossil fuels. You can take methane and crack it into hydrogen and carbon. But obviously, there's other ways to skin this cat, and that's what we're going to take a deep dive into on converting electricity from green sources, wind, solar, batteries, whatever other green sources. There's many ways to make electricity, but wind and solar, as you said, are the cheapest sources of clean power now. Well, cheapest sources of grid power globally, and now the fastest growing sources of new power on the grid. Because of that, right? We're seeing the energy transition unfold before our eyes, not so much because humanity cares about sustainability. We're too short-sighted. We're just not designed. I'm an ecologist by training, and so I like to think on long time scales. Humans evolved in a world that was completely empty. And we were just very focused on short-term survival because it was a dog-eat-dog world. And now we have a problem on our hands, which requires us to think long-term. And we're just not very good at that. We just haven't been forced evolutionarily to think long-term. And now we need to do that. Filling the atmosphere with 800 gigatons of CO2 equivalents is now causing runaway climate change and climate chaos, as I like to say. And that is just not going to be pretty for our ancestors. I mean, for our children and our children's children. So tell us about Rondo Energy. What are you doing? And then you could share your little mini deck there with our viewers who are on the YouTube. And if you're not on the YouTube, just go to cleanpowerhour.com, and there's a little YouTube icon in the upper right-hand corner. Click on that icon, and you'll find this channel. So go ahead, John, and tell us about Rondo.
Yeah, thank you. And thank you for that introduction, because you touched on a ton of topics that really resonate. The energy that's used to make steel, cement, fertilizer, plastic, baby food, every one of our commodities that our society uses and depends on is industrial energy. Industry is the largest portion of total world energy use. Around the world, industry uses more energy than transportation or residential or commercial other areas. According to the IEA, 3/4 of the energy that's used by industry is not in the form of electricity, but it's in the form of heat, whether it's refining fuel or cooking cement, cooking limestone to make cement or melting steel. That high temperature heat is a large portion of the cost of production of all those commodities. And it is on its own about 1/4 of all world greenhouse gas emissions, because it's a big portion of the cost of producing commodities. And we have not seen a transition to decarbonized heat for these processes today because it's been more expensive. You talked about taking the long view. It's hard to do that, to take the long view, if you're going to switch to a fuel that's 5 times more expensive than business as usual and make your factory less competitive, right? It is a genuine challenge. And we're really excited because Rondo has an important piece of solving that challenge. While other approaches like carbon capture create permanently higher cost for commodities, and a future where, our children, our children's children will have it more and more challenging to keep putting carbon in the ground and spending more money for a pound of concrete than they do today. We're at this moment where the amazing accomplishments of the wind and solar industries have brought the cost of renewable electricity on just a raw energy basis, not just below the cost of conventional electricity, but below the cost of burning fuel. But they're intermittent, and they're in the form of electricity, not heat. So we are at a moment where, if there were a technology that could take that intermittent electricity and turn it into continuous heat with suitable cost, efficiency, safety, ability to do it at large scale, and temperature, we could have a path for economical decarbonization of industrial heat. We could have a path to eliminate 6 gigatons a year, 12, out of world emissions, about 25% of total world emissions. And we could be doing this rapidly now, because around the world, the primary energy is becoming cheaper than fuels. Rondo's business is building a battery that solves this problem. It's a heat battery that captures intermittent electricity, and as you said, either through the grid or through local wind or solar generation, and converting that electricity into heat, just the way your toaster does, just the way your hairdryer does, with hot electrical heating elements that are made of a widely available iron alloy wire, and then storing that heat at a couple of thousand degrees Fahrenheit, over 1,000 degrees C, in thousands of tons of brick, so that you take 1,000 tons of brick, you heat it for 4 hours with electricity, with 100 megawatts of electricity. You've stored about 300 megawatt hours of energy, and then you can deliver that energy continuously, either by with a built-in steam generator. About half of the world's industrial energy is delivered as steam, or directly as superheated gas into an ethylene cracker or a cement kiln or a steel mill. So Rondo's core contribution, we found a way to combine two century-old technologies, the brick material that the steel industry has been using for heat storage for 200 years, with the same heating elements that are in your toaster, with a new geometry, a new system design that's now patented. And this is a technology that applies across all kinds of industries, everything from making cement to baby food, and around the world, across Europe, across the Middle East, across North and South America, Australia, lots of places in the world. Wind and solar today are cheaper, so that there are tailwinds for doing this.
Yes. You mentioned 100 megawatts of electricity and 1,000 tons of bricks. Is that a 100 megawatt battery? 1,000 tons of bricks?
Yeah. So as it happens, it turns out that we store energy in brick. It turns out we store about the same amount of energy per pound as a Tesla battery pack. We store it in the form of heat, not electricity, and at about 5% the cost of that lithium-ion storage.
Yeah.
And yeah, so as it works out, 1,500 tons of brick stores 300 megawatt hours of energy. Yeah, so we build units that are industrial scale. They charge at up to 100 megawatts. They deliver 20 or 30 megawatts continuously. That's a Rondo Heat Battery.
Okay. And what is the physical footprint of a 20 or 30 megawatt?
Oh yeah, that actually is a really important question, because you can't move heat very far. So heat batteries need to be tied into the industrial facilities that are using heat. It worked out that as it happens, the number is 1 megawatt hour per square meter. We're just about the same size, just a little bit bigger than gas-fired furnaces and boilers of the same heat capacity. And because there's nothing in a heat battery other than steel, cement, and brick, there's nothing that can combust. They're safe to put in industrial facilities.
Okay. And what is the status of the company?
Rondo started 2.5 years ago now. At the end of last year, we raised a first round of financing that was jointly led by Bill Gates's Breakthrough Energy Ventures and Energy Impact Partners. EIP is a venture fund focused on deep decarbonization, whose investors are the electric power industry. Joining those were two international cement manufacturers, and the company is now in production for its first heat batteries. We'll be delivering first customer units this year. Yeah, and the other major project that's been announced just in the last few months, we were in partnership with two cement manufacturers and a leading builder of cement plants, awarded a grant by the Denmark government for a pilot of a true zero cement plant. intermittent electricity to cement with zero emissions. So we're working in a number of sectors around the world today, and we'll be in large-scale production next year.
Hey, everybody. Thanks for listening to the Clean Power Hour or viewing it on YouTube. We do have a great YouTube channel. If you're not subscribed, please go to cleanpower.group and hit that YouTube icon and subscribe to our channel. Of course, you can find all of our content on your favorite audio platform as well. So please give us a rating and review. Back to the show. You mentioned Breakthrough Energy Ventures. Isn't Shell Khan there at Breakthrough?
Shale is at Energy Impact Partners.
Oh, Energy Impact.
Shale is at EIP.
Sorry,
That's right. Yeah.
That was just a glitch, conflation there. And so, yeah, check out Shale's podcast.
Yeah. Catalyst. He's covers all kinds of very interesting.
Catalyst, indeed. Yeah. His new show. That's one of my favorite podcasts. And Shell came from Green Tech Media before he became a venture capitalist. But so you're in production, so to speak, right? You're actually manufacturing these. Do you literally just call them batteries, or do you, when you're talking to an industrial customer, how do you refer to them?
It's just the way I spoke to you about it. It's a heat battery that's going to replace one of your existing or all of your existing boilers or furnaces, and to drop in to repower your process so that instead of buying coal or natural gas, you're buying electricity. Now, you may be participating in an electricity grid where you can absorb energy that otherwise would have been curtailed or sold at negative price. There's a ton of areas in the United States, mid-continent, where wholesale prices of electricity are negative about 20% of the time. And the opportunity for energy storage units to capture that energy and put it to beneficial use in industry is phenomenal. There are other places where you're going to build new wind or solar generation, and now your factory is going to no longer be subject to the volatility of fuel prices. You're going to have a locked-in low cost of energy to run your factory. But Rondo's piece of that is these things that we call heat batteries.
Yeah. And so I guess this is all well and good, right? We've got cheap renewable energy, more and more readily available. Of course, we're in the process of building 50 to 100 terawatts of solar in the next 30 years. And it took 50 years to install 1 terawatt, as Matt Campbell likes to point out. And now we are, we're accelerating. We have the IRA, the Inflation Reduction Act, at our back now, which is also a good catalyst for the clean energy transition. But how do you see the sheer economic problem now, I guess, of getting these industrial users to open their eyes and consider a decarbonizing solution like Rondo?
Okay, you made several very interesting points. And so, first of all, if I'm right, and you know better than I do, there's about a terawatt of wind, a terawatt of solar installed worldwide at the end of this year. According to the IEA, to repower industrial heat, we need between 9 and 10 terawatts of new generation, like 5x more than there is in the world today, just to supply the industrial heat that was in use in 2017. And of course, that's growing as the world gets richer. So we are talking about a giant new market for renewable energy that solves the problem that's being unlocked. Now, one of the things that's going, and that renewable energy does not necessarily need to flow through electricity grids. And it doesn't need to be time matched with existing electricity demand, because these are heat batteries. They take energy when it's available. average interconnection time to the electricity grid in California is now more than 7 years. A friend told me it's about 10 years in Oklahoma. We're seeing wind and solar in the grid slowing down because of that. This is a new type of load where a huge amount of new generation can be built, replacing these loads that's near the factories somewhere. And because the battery only is taking energy when the wind or solar it needs no grid connection at all. A number of our early projects are not connected to the grid. So we do see there's a very significant opportunity. We're talking about 25% of total world CO2 that we can knock out this way. But to your second point, I don't have to ask anybody to open their eyes about decarbonization. Every industry around the world is asking, how do we do this? But the options that have been out there, switching to biofuels and limited supply and 4 times, 5 times more expensive, hoping that carbon capture would not triple my operating cost. You mentioned hydrogen earlier, which is 2 or 3 times more expensive as a source of heat than what we're doing at Rondo. The existing options have not been great. One of our advisors says, look, we're a new tool in the toolbox, and we open this pathway to decarbonizing at much lower cost. So the real matter is we need to bring this technology to scale, which we're doing, and the world needs to understand that this option is available. The CEO of one of the large renewables developers recently said that electrically heated thermal storage for industry is an inevitable $1 trillion market. We agree. We're pretty sure we're the leader in that market, or at least one of the leaders. And I'm thrilled about it because this really is a big hammer, both for industry in leaving our children a world where industry is operating on lower carbon, zero carbon energy. You know, people build solar fields and they finance them for 20 years, but then it lasts another 20 years. You know, we're creating a long-term, low-cost energy that's zero carbon now, and we can do it at scale now. As you can tell, I get pretty excited about the prospect here. You know, Our plan says Rondo, with wind and solar partners, we can knock out 15% of total world CO2 in 15 years. We have carefully chosen materials that are available everywhere in the world. Fundamentally, brick is made from dirt. The right kind of dirt is available everywhere. So we're not using critical minerals or anything that's a refined product. We're really, humans have been making bricks from clay since the dawn of civilization. And we can do it at scale now.
I want to talk about some specific applications, but before we do that, one of the niggling thoughts I have here is, well, this is all well and good as long as you really do have renewable energy accessible. There's plenty of sunlight and wind, but are we capturing it in the right places to make it available to these industrial processes? Let's talk about the Midwest, for example, right? The solar revolution has only just begun here in the Midwest. You're 30 years in California to that transition, and California is by far and away the most mature market. And on a cool spring, windy, sunny day, California is reaching a very high penetration now of wind and solar on the grid.
Indeed.
And that's a wonderful thing. I'm fully supportive of that. Here in the Midwest, we still have lots of cheap coal power. It is in transition, and we are closing coal plants and natural gas plants by the dozens. And so it is happening, but it's quite conceivable that you're going to find a steel plant in Indiana that doesn't necessarily have a supply of clean green energy readily available. What do you say to those owners? Of course, they have grid power, but we have to be careful, right? Because if the electricity is made with dirty coal, then you're not decarbonizing the plant by installing a quote unquote carbon-free battery.
Yeah, that's a great point. And a lot of the work there's been a lot of work done on industrial electrification. We're going to replace combustion with electricity, and electric boilers are low cost. Electric furnaces are low cost. You're at home, you can buy an electric stove or a gas stove. The unique thing about what Rondo's doing is building a heat battery. So it's an electric boiler or an electric furnace that takes all of its energy every day only when particular generation is available. Because if you install an electric furnace in that steel mill you're speaking of, part of the day it'll be powered by wind, and part of the day it would be powered by coal or whatever is providing the baseload electricity. So that's the core value of a heat battery, is that it'll take we can command it to take all its power input only when clean electricity is available. And you're right, the transition to clean energy has gone at different paces in different places. That's partially been because of the resource and what it costs. But we are now at this moment that, including in Indiana, new generation can be built somewhere near those heavy industry that will deliver energy cheaper than the folks who are today burning natural gas as their source of energy right now. And that's a pivoting point in the world, that Rondo's focusing on the places where that price spread is biggest. Southeast, the Southeast US, a number of international locations all across Europe, the Middle East, Australia. But mid-continent US, it's the wind industry that has delivered super low prices, and the solar industry, as you say, is catching up. And over the next 5 years, as we look at things, as we look at forecasts from the National Renewable Energy Lab, we are entering this world where it goes everywhere.
Yeah, I would love it if Indiana would allow for industrial solar. They don't allow a power purchase agreement, for example, in Indiana today. And that is a barrier to entry. Illinois is friendly, but we also have rules that say, for example, you can only install a 5 megawatt AC solar array on an industrial facility. Many of my industrial customers could use 20 to 80 megawatts of solar electricity in their plants. And then you're talking about what's called a qualifying facility as far as the grid operator is concerned. And that's a whole other ball of wax. And so the devil is in the details, and I'm not trying to rain on your parade. I'm just trying to let our listeners know that you have to really know what's going on in your jurisdiction, in your state, in your ISO or RTO, and to figure these things out. Let's talk about the segments that you're going after. You have 4 broad segments. And then
if I may, before you change topics, I want to just talk about those rain clouds you just talked about, because those rain showers exist. And, we try to arrange our parade route not under those clouds in particular.
Yeah.
And you picked an example of somebody who's got like a 50 or an 80 megawatt load. We're working with a cement plant here in California. They have a 55 megawatt electric load. They can get a PPA for their 55 megawatts. They have 1,000 megawatt heat load. It's 1,000 megawatts of heat, 55 megawatts of electricity. The solar facility to repower that cement plant will be about 2.5 gigawatts. And it will have no connection of any kind to the grid. It'll only be connected to the heat batteries. So the ISO rules, the electricity rules have nothing to do with it. So we are really actually focusing on where are the places where generation can be built without touching the grid at all. So it's not
Mm-hmm.
behind the meter. It's not
Mm-hmm.
a QF. It has
Mm-hmm.
nothing to do with the electricity grid. It's just an industrial heat project. And those are the places where those regulatory matters that you mentioned are sidestepped for now. They certainly need to be fixed as we go forward,
Yeah.
because only some industrial facilities are located in places where you can put generation nearby. A huge portion of the transformation of the American grid is going to need those regulatory changes and fix those rain clouds you were talking about. But there is about, here in California, for example, about 40% of the industrial heat can be built from local generation. We burn more natural gas in California for industrial heat than we do for electric power. We have about 28 gigawatts of PV in California today. It's going to take 100 gigawatts to just repower the industrial loads. About 40 gigawatts of that can be built with no grid connection while we work on, okay, let's get the regulatory frame in place so
Mm-hmm.
that we can go all the way to deep decarbonization.
Yeah. And that I think that scenario works. The grid defection scenario, let's call it, works when the industrial plant, is in a rural landscape and you have lots of land available. And
Now,
that is,
we
that
weren't
is
talking
many
about
places.
defection.
We are swimming in real estate.
That's right. We weren't talking about defection, though. That is, I'm interested in solving the 1,000 megawatt problem. The customer may well still have their electricity connected to the grid because they need all the reliability and all those services. We're just saying we're not turning off their electricity supply. You and others may be doing that. We're saying we're going to turn off your fuel combustion,
Mm-hmm.
and we're going to replace your fuel combustion. This is separate from your electricity.
Okay.
Yeah.
All right.
Yeah.
Very cool. Point well taken. Point well taken. So thank you. Let's talk about segments: process and power steam, mineral calcination, direct process heat, and combined heat and power are the four major
That's right.
market segments that you're targeting on your website anyway. Can you give us a soundbite about each of those, and what are some practical examples of where Rondo can plug and play?
Sure. We build a single heat battery that stores heat at very high temperatures, but it's configurable in how it delivers that energy. A little less than half of all the industrial heat in the country is delivered as high temperature steam, whether you're cooking baby food or dog food, or you're making refining petroleum fuels or making chemicals. So the steam generating heat battery does apply across a number of industries. Now, there are other industries, if you're producing lime or gypsum drywall or cement or steel, where you use energy at higher temperatures and often in the form of superheated air or superheated another gas. So you can take that steam generator off the heat battery and we can connect directly to higher temperature applications. So when we look at verticals, we are primarily focused on where is the electricity supply favorable, and then we'll provide the configuration of the heat battery that matches that. So this does apply to a lot of verticals, but you touched on this matter of what is the electricity supply. That's where the immediate places where we create value. So we have an application engineering team that is working with industries across making aluminum, copper, lithium, other iron, a number of different commodities in different places in the world. And not surprisingly, the earliest projects are in places where renewable energy costs are very low and the applications are easy.
Mm-hmm. Mm-hmm. But so, I mean, you mentioned a few specifics there with like food processing. What is this mineral calcination business? What industries are you talking about there?
Oh, sure. when you make cement, you take limestone and you heat it and it boils the CO2 out of the limestone. It's called calcination.
Okay.
When you make aluminum from ore, there's a multi-step process where the ore is dissolved and then dried and heated to drive water out. It's another kind of calcination. So there are a number of processes making everything from lithium to the elements in the glass of your smartphone screen. There are a lot of processes that use high temperature heat that way to change a mineral in its production. Nickel, copper, lots of those things.
Okay.
Those are kind of specialty areas, but one of them, they're all in. They're about 10% of total industrial heat. They're 5 or 6% of total world energy is in these very high temperature processes.
Mm-hmm.
And Rondo is the only technology available so far that can use intermittent electrical energy to deliver the energy in those processes. So we have a key role in decarbonizing mining and minerals and metals.
Got it. So what else should our listeners know, whether they're energy professionals or facility owners who are looking for ways to decarbonize their thermal processes? I'm curious if industry, you said earlier that you think there are many industries that are chomping at the bit for technologies to decarbonize. I would love to meet those CEOs because I'm beating the bushes day in and day out, trying to get companies to buy, for example, solar power purchase agreements. And you'd be amazed, but it's not very many that respond, "Oh yes, we're interested." It is 99 no's for every yes that want even more information. And so maybe I'm in the wrong industry. I'm just curious, like what kind of a response is your sales team getting so far from industry?
So I think it's an interesting point that you make. And I think it might be because we're working at a slightly different scale on a different problem. For a lot of industries, right, they look at when they have an emissions reduction goal at corporate, that emissions reduction first is scope 1, combustion at my own facilities. Some folks also have scope 2, combustion associated with the energy that I buy. And then scope 3, emissions associated with the materials I use or the use of my product. And scope 1 for lots of large industrials, that's the big dog. That's the big thing. And a fair amount of attention is going at that. And one of the guys that we were working, one of the plant managers that we're working with said, look, I've done lots of energy efficiency projects that have already knocked me down by 6% or 8%. I'm not looking for 5% solutions. I'm looking for 90% solutions. And what Rondo is doing is a big hammer. We're going to turn off all of your combustion. And so that's very interesting to the chief sustainability officer or the CEO. We're a big hammer in the corporate decarbonization. But if that corporate goal is misaligned with the plant manager, if decarbonizing is going to raise costs of production, that creates a lot of internal organization stress. So we are focused in areas where we really clearly understand from year one, we will deliver lower operating cost at the same time as we eliminate scope 1 emissions, and in some cases, a lot of scope 2. So that when the plant manager and the CEO's goals are lined up, things tend to move. And it's not an overnight process. right? In often cases, it's a multi-year process, planning and budgeting major facility changes and energy procurement. I think one of the things that we do see across industry is growing sophistication on energy procurement. The rise of PPAs, understanding that I can move away from a volatile to a more fixed energy infrastructure. Lots of organizations that have done supply chain management perfectly in what are the raw materials they use, they're still coming up the curve on energy as the supply chain. And the work that you're doing in trying to drive PPAs is really valuable. And there's an education matter. We are right at the beginning with this new big hammer. We have an education matter, and but we have been focusing on those who are already seeking large. How can we make a big change in our scope one? Rondo has a really important answer that applies across a bunch of industries that has this beneficial characteristic that it's both lower cost and a 90% reduction.
Yeah. You said a couple times something that I'm just curious about too. You say where solar and wind are cheap. When you look at the landscape in the United States, is there really a big difference in the cost of large scale? Because let's just say we're talking about, 20 megawatt or 100 megawatt solar facilities, just to use some round numbers. Is there a big spread from region to region?
There is, and big spread. I think it's probably 30%, something like that. Mm-hmm. And we're doing a lot of work in mapping where are the areas of greatest opportunity. Up and down mid-continent, from West Texas up north through Iowa, and there's a wind belt where wind prices are the lowest. Now, there are other wind belts as well. You pointed out where the solar facilities are cheapest is where it's sunniest in the year. But both of those technologies, the core technologies, come down in cost so much that the area where the economics work has grown dramatically. We see the same thing around the world. But part of the issue is also, what is the cost of the alternate energy source? When we look at Europe today, there are PPAs out there that were written last year that are at 10% the cost of today's cost of natural gas. Now, a year ago, they were only a third the cost of natural gas. So there are places in the world where, it's low cost, but compared to what? It's compared to what is the energy source that industry is using today.
Yeah. Okay. Well, is there anything that we have not discussed about Rondo and the economic opportunity that you wanted to touch on?
Well, thank you for the tough question. I think there are a lot. We could go on for a while, but we are just now emerging from years of technology and prototype development into our first customer installations. We have just built the commercial team so that we can work with more than the few initial customers that we are working with. I'm very grateful that you've taken the time to talk to me and help educate, your world of folks, because again, we think that we are unlocking a giant new business opportunity for renewables developers and a giant opportunity for industry to decarbonize faster and at lower cost than any other pathway we know of. And, we're excited to be able to make this contribution. And I look forward to staying in touch as we go forward with these initial projects.
Excellent. Well, you can check out rondo.com, rondo.com, to learn more about Rondo Energy. And you can find all of our content at cleanpowerhour.com. please give us a rating and review on Apple and Spotify. That helps others find this content. We need tens and tens of thousands of more energy professionals to come into the clean energy transition. And that is one of our missions here at the Clean Power Hour, is to speed the energy transition. I want to thank John O'Donnell for coming on the show. And how can our listeners reach you, John?
Tim, thank you so much. Yeah, reach out to me at Rondo. I'm john@rondo.com.
Wonderful. Well, there you have it. I'm Tim Montague. Let's grow solar and storage. Have a great day, everyone.
Thank you. Thank you.